How to program a microcontroller using embedded C. Imagine turning a tiny chip into a smart device that can control lights, motors, or sensors. That's what programming a microcontroller with embedded C can do for you. It's like giving hardware a set of instructions to follow. First, you need to understand the microcontroller you are working with. Find out its model, like the 8051, PIC, or ARM Cortex-M. Read its datasheet carefully to learn about its memory, input-output ports, timers, and special function registers. Knowing the hardware limits helps you write efficient code. Next, set up your development environment. Pick an IDE compatible with your microcontroller, such as MPLAB4PIC or Keil48051. Install the right embedded C compiler, like XC84PIC or ARM GCC4 ARM chips. Connect your microcontroller board to your computer using a programmer or debugger device. Now, it's time to write your code. Start by including the microcontroller-specific header files that define hardware registers. Use data types like unsigned 8-bit or 16-bit integers to match register sizes. Configure the hardware by setting the registers for ports, timers, or communication protocols. Write your main program inside an infinite loop so it keeps running. Break your code into functions for clarity, and use interrupt service routines to handle events like button presses or sensor signals. For example, you might read inputs from one port, process the data, and output results to another port. Once your code is ready, compile it. This turns your C code into a binary or hex file that the microcontroller can understand. Use debugging tools to simulate or step through your code, checking register settings and timing. When everything looks good, load the binary onto the microcontroller's flash memory using a programmer. After programming, reset the device to start your program. Test your project in the real hardware environment. Use LEDs, serial output, or oscilloscopes to see how your code performs. If needed, go back and modify your code to fix bugs or add new features. Remember, embedded C allows direct access to hardware registers through pointers or predefined names. Bitwise operations are essential for controlling individual bits in registers. Writing interrupt routines makes your system responsive to real-time events. Be mindful of memory constraints by keeping your code lean and efficient. Use hardware timers or delay loops for precise timing. Whether you're controlling LEDs, reading sensors, or communicating with other devices, programming microcontrollers with embedded C is a powerful skill. It's the foundation for creating embedded systems that make everyday electronics smarter and more capable.